Hello again. Now we're going to talk about finding a linear regression using our graphing calculator. In this problem, we're going to find the line which best models this data. And we're going to use that model or that function that we've created, the estimate function, to predict. So in this situation, we have study time compared with grades. A math instructor asked her students to keep track of how much time each spent studying a chapter during the unit. She collected the information together with the test scores from that unit's test. The data are listed in the table below. So you will notice we have study time in X hours, 23, 10, 8, 21, 17, 7, and 13, which each match up with a test grade or a Y value measured as a percent. So hours spent studying compared to the test grade. So let's look at putting this into our calculator. Of course, we've already got our diagnostic on. You can turn that on by choosing second 0 under the catalog. I'm just going to go to Stat, hit Enter to edit, and then I'm going to input my data. So let's see, we got 23, 10. You want to make sure that you enter all of your data correctly. Take a second, make sure you have double checked this because the calculator is going to give you the correct answer based off of your inputs. And if you input it incorrectly, your answer won't be the correct answer for the problem. 92, 87, 84. And I noticed that they each match up: 2392, 1087, 884, 2185, 1782, 770, and 1398. All right, so let's, now that we have our data in, let's look at the graph. So we're gonna hit Y equals. In order to look at the graph, we'll just go ahead and arrow up, turn that plot on. Now it's highlighted. I'm gonna hit graph. I may not see my data on the screen, but we have some fun zoom features. If I hit zoom and choose option 9, zoom stat, that's going to fit my data on the screen. Now, in this question here, does this graph look linear? Does the data create a linear scatter plot? And you guys would likely answer, not really. It doesn't really look like a line. Maybe if we removed 2 pieces of data, which we might call outliers, it would look a little more linear, but it's not a perfect line. All right, so regardless of whether or not it looks like a line, we're going to model this data with a linear function. And the way that we do that is we hit Stat, we arrow over to Calculate, and we choose option 4, Linear Regression. So 4, enter all the way down. If you so desire, you can store your regression equation into the Y equals by hitting the vars button, variables, and then arrow over to Y variables, enter, choose your Y1, and calculate. So we have Y equals AX plus B. Y equals 0.596. I'm going to round that to 3 decimal places. 596x plus 7.998. 76.998. Again, rounding that to 3 decimal places. So Y equals AX plus B. You plug in A and you plug in B, and that gives us a function, which you see over here on my written out screen, which models our data. We can use this function to predict. So in this situation, we are asked to predict a student's score if they study for 5, 12, or 20 hours. And that is just as easy as taking the 5, the 12, and the 20 in. Now I only worked the 12 hours on my screen, but since I have plugged this function into my Y equals, I can go to my table and I can use my table to help me evaluate it. Now, one thing, most of you probably already have your calculator set to automatically tabulate the independent variables and the dependent variables. I prefer to leave mine on ask and use ask mode. So that way when I go to the table, it's not already filled in. So I'm going to go to table set, ask, and now my table will look blank. I want to know the output when X 5 hours, X is 12 hours, or X is 20 hours. This is what we predict a student's score might be if they studied for 5, 12, or 20 hours. Okay, so going back up here and thinking about this scatter plot graph, let me actually just go to the graph there. Thinking about this line, which is modeling our data. If we look at it all together, you do see that that line appears to be, doing its best job to go through all of the data points. And as I may have mentioned before, we have 2 pieces of data, which maybe represent an outlier. So if I were to ask you and say, well, how confident are you about using this regression model to predict students' future test scores? Well, that comes from looking at the R value. So the R value, when I did stat, calculate, oops, let me do that again. Stat, calculate, option 4, linear regression, and I arrowed all the way through there. My R value, my correlation coefficient, was 0.4333. And I like to think about that as a percent, 43%. So that's telling us how good this model is, how confident we can feel. This is our level of confidence for using this model to predict a future student's grade. Now, as you can see here, because we have a positive slope, the line is going up, we get a positive correlation coefficient. Now, 100% or R equals 1, that would mean that all of the points would lie on that regression data. So 0.91 is saying that's a high positive correlation. 0.42, we've got 0.43 here. That's a low positive correlation. So if I get a low positive correlation, I would be inclined to say that this is not a good model, that this function that we found, the 0.596x plus 76.998, is not a good predictor for what students' grades would be. So that'll conclude this video. Just a reminder, if you did turn your stat plot on, go to your y equals and turn that back off because it's going to cause a problem for you later and you're going to try to graph something and it won't work. And 9 times out of 10, when a student comes to me and asks me that question, I'm able to go back and say, oh, your plot 1 is on. Let's turn that off, and it fixes it right away. So turn that back off when you're done looking at your scatter plot. As always, if you have any questions, feel free to call me or email me. Good luck.